this is equal to summation over b vb r summation of summation over b of ab, summation of all charges, and integral ds dot, well, the electric field for a point charge, we derived this its expression, and that expression can be written as ds dot r minus rb divided by r minus rb modulus times 1 by r minus rb whole square, well, the magnitude square. Now why did I write this term over here? Well, this term is significant, we know that, but why this term? As you can see, this term is basically this term is basically, we can say this term is the r vector, the position vector. So the electric field is a vector quantity, just to remind you, and hence this has a position vector. So this is the magnitude square, and we got it. So since this is r dotted with some normal vector over here divided by r squared, you can see this form over here, this form, and it matches that form. And so I'm going to write that thing as summation over b eb contour integral over the element d omega b. So you can see why I wrote that, because you directly see the connection here. And now once I wrote that, well, this ds missing over here, ds missing over here, yeah, so that's it. And once I wrote that, you can see that there are two possibilities now. Two possibilities. The first possibility is that this surface S is two-dimensional surface. It's a closed surface, and hence the charge could either lie outside, in which the contribution of this integral will be 0. Outside will be 0, and inside it will be the whole solid angle, and the total solid angle is equal to, if you see over here, it is integral of sine theta d phi. Integral d phi is 2 pi, sine theta d theta is 2, so the answer is 4 pi. So the total solid angle is 4 pi. So you can see that the answer to this one is equal to 4 pi in that case. That is equal to 4 pi. Well, that is equal to 4 pi. So we are only interested in this inside case, because outside in any way is going to be 0. So I would like to write, since this integral is equal to this first integral that I wrote, I would like to write I would like to write that this integral that we first wrote, well, this is already a vector, because ds vector is already a vector, because I wrote this ds vector as ds dot n hat. So this already is dot producted with the n cap vector. So just keep that in mind. So that's what I forgot to mention about my notation. Dot er is summation over all the b's in v of 4 pi times eb. E by eb was outside, it was a constant outside, so it is 4 pi times eb. So you see, we are not interested in the, again we have to, I just want to say that we are not interested in the outside case. It doesn't contribute here because this is one of the case, and in the second case it is 0. This is when when eb is inside S, and this is when eb is outside S. So you see the differences between the two things, and that is the thing. Okay, so the next topic, before going to the next topic, I would like to stop here, and I would prefer to stop here because I would like to I know that many of you know direct delta functions already, the concept of distributions, but since again it's a mathematically oriented course also, and I want to mention the mathematical methods for all the audiences, and I would still encourage you attend that, you see that lecture, because it would be a review for you. And the direct delta functions and distributions, it is a vast subject. Distributions is a vast subject, and so we will need that, and so I would give a lecture on that mathematical supplement. So in the next lecture I will talk about that, and on that note I would like to end it here, and please tell me in the comments if I have gone wrong somewhere or there is any error in the lecture, or if I have not explained any of the things properly, so that I could correct it in the future. And okay, thanks for the day.